Alright guys, so let's get started. So today we are going to talk about keywords in Scala. Okay. Now, what is a keyword, right? So that's the important thing. So see, every programming language would have a reserved words, okay? And that word has a particular meaning, right? For example, we use well or where to define a variable. That means when somebody says well, it is understood that you are going to define a variable, right? So those words are called as reserved words and they are called as a keywords in Scala, okay? So the keywords in Scala, like if I go by number, then they are around 51. Okay, so we'll talk about that. What are those over the period of time? So I'll refer my notes while presenting you this so that I don't miss anything out, right? So there are 51 keywords in Scala, and this is from Scala 3.x. Okay, so they have introduced a couple of new keywords and they have deprecated a couple of new old keywords. So let's put them together on the board. So what I'll do is I'll classify them as per the usage, and then we'll go ahead with that. Okay, so I'll start with class label first. You have class label, then you have exception handling, then you have data types label, then you have literals, then you have modifiers, then you have conditions, then you have loops, then you have functions, then you have symbols, and then you have etc. Okay, so like based on the usage, I've just broken them into this like categories. Let's understand what comes under each of these categories. Okay, so at class level we have around 13 keywords, and they are class, to define a class, right? Object, you can also have object there. Extends, to extend from another class, right? Traits, you have classes, objects, traits, they are high level containers. You have import, which can be used to import certain classes and packages. Then you have package keyword, to create a package, right? You have super keyword, okay? You have new, to create new object. Super is to refer to the parent class. You have with, which can be used when you want to extend from multiple like a class or interface, like you use with. And then you have implicit can be at class level, we'll talk about that. We have sealed, okay, they are also at the class level. You have enum and export, okay, so these two are newly added in Scala 3.x, right? So 1 2 3 4 5 6 7 8 9 10 11 12 13, so there are 13 class level keywords. Okay, and we will be learning all these things as we move on with the course. Right now we will not be able to like demonstrate everything. As we move on with the whole Scala program, we will learn about this. Okay, now we'll go to exception. So exception wise there are 4, right? And what are those? They are try, catch, right, throw, finally. So these are the 4 exception level keywords. They are try, catch, throw, and finally is. And remember, there is no throws keyword. Okay, so like you have in Java, there is no throws keyword. So I'll say no throws. There is no throws keyword. Okay, next, data types. Data types, I have classified them into 3. Now, well, where, and I've added one more here, lazy. Okay, so we'll talk about that later. I have also added them lazy because that is also used in association with well or where. Okay, next. Now you have literals. So literals means the constant which you basically use, and we have also classified them into 3. They are true, false, and null. So these are the 3 literals. Now we have modifiers. Modifiers are classified into 4. The abstract, okay, final, protected, and private. So you have abstract classes, right? But then we did not take it to the class level because we wanted to keep them under the modifiers. Okay. Now you have conditions. So conditions, we have 5. You have if condition, else condition, you have match. We've already seen that in our previous example, match cases, right? So with match, you also use case. Now case can also be used as a class level, but then we've just kept it under conditions. Okay. Then you have then keyword. Okay. So this is also new to Scala 3.x. These are also new to Scala 3.x. Now let's talk about loop. So you have 4. So loop, you have do, you have while, you have for, okay, and then you have yield. So do, while, for, and yield. Functions, you have 3 at functions level. So they are like def, to define a function, and override, to override any function, and then return is a keyword when you want to return something from a function. So I've placed these three under your function label. Next you have symbol label. So at symbol we have placed 10. They are all symbols. Okay, so the symbols are colon, okay, you have equal to, okay, you have equal to and greater, okay, you have this symbol which is used for array, right, and then you have this symbol, and then you have this symbol, and then you have has, and then you have at the rate, okay, and then you have equal to, greater than, and then you have question mark equal to greater than. Okay, so these are the 10 symbols which are reserved keywords, and they are as part of symbol. Okay, now the etc, they are like, I could not classify them right now, so I've just kept it here in the etc, and they are like type and given. Okay, so these are the keywords in Scala 3.x, and the count, if you start counting them, they totally like sum up to 51. Okay, now this given is also is introduced in Scala 3.x. okay, so we understood that there are few new keywords in Scala 3.x. Apart from this, what is interesting is these are called as the reserved fixed keywords. Okay, these are the hard keywords. But Scala 3 has one more concept called soft keywords. Okay, and they are 14. So 14 soft keywords are also present, which you can also call it as a keyword. So these soft keywords may be promoted to a real keyword probably in the near future. But let's talk about that. I'll list that also down. So they are, let's say, as, okay, derives, and, okay, extension. Let me write it down. And you have infix, inline, then you have opaque, you have open, transparent, using, and they've also given few symbols like pipe, star, plus, minus. So all these, I have not classified them together here because they are actually soft keywords. Okay, and they could be used either in class level or variable level or method level or whatever, right? But then we will try to explore as much as possible as we move on with the course, right? We'll try to see if we can explore all of them together, right? So these are the list of all the keywords in Scala 3.x. Okay, so we understood that there are 14 soft keywords in Scala, and we have a regular 51 keywords. So altogether, if you see, 51 plus 14 would make it 65 keywords. Okay, so you can say that roughly there are 65 keywords, out of which 51 are reserved. Okay, what is important for you to understand are these new keywords, whatever was introduced in Scala 3, right? So now couple of things I want you to understand is there is no public keyword. Okay, there is no public keyword in Scala, right? So like you have a Java, you have a public class, right? And the default, by default, if you don't specify anything in Java, then they take the access specifier as default or no access. But then you do not have such concept in Scala. Whatever you define a class, by default it will be treated as a public class. Okay, now there's no throws keyword, right? So no throws. We used to have this in our exception handling whenever your method wants to throw an exception back to your child, right? So you do not have that throws keyword. Instead, you have @throws annotations, right? Instead, you have @throws annotations. Okay. Next, there's no break. There is no break keyword. So break is usually used to break the loop, is not it? Like you have a loop, and if some condition is met, you would like to get out of the loop. So you basically use break keyword in Java, but you do not have the break keyword in Scala. Instead, you have a break as a function. We will see that as we move on. Okay. Next, you do not have a static keyword, right? So static is basically a class level variable in Java. You do not have a static keyword in Scala. Instead, you have something called object. Okay. So we will learn about this as we move on. So if you want to deal with static variables, then you should basically talk about object. You should basically think about object. So we'll look into that little later. Now, so if you look into this whole list, I have also not listed two things. Okay, one is for some, and another one is this, right? So these two are not even listed as part of the keywords. So most probably they are removed, and that's the reason we do not have them in a document itself. Okay, next, there is no plus plus and minus minus operator, right? We like we used to say int I equal to 10, I plus plus, I plus plus, right? So those plus plus and minus minus symbols are not available in Scala. Okay, if you want to increment or decrement, you should always say x is equal to x plus 1 or x plus equal to 1. So you'll see them later in the program. Okay, now the interesting one more point is, see, you have a do and you have a while. Okay, but let me tell you, do while is removed. Do while condition is not available in Scala 3.x. So do while used to be there in Scala 2, but in Scala 3 there is no do while loop. Okay, so you have a for loop, you have a while loop, but you do not have a do while loop. Okay, and this do and while would be used for different purpose. We will look into the use case as well. But right now, just understand that there is no do while loop in Scala 3.x. Do is still a keyword because it is used for something else. Okay, whereas this while is for your while loop, but there is no do while loop together in Scala 3.x. Okay, now that's what we wanted to talk about. And if you see, I also did not find underscore as a keyword, right? We used to have underscore as a key as a reserved word, but I did not find underscore as well in this Scala keyword list. So all the symbols we will be exploring when we start working on it. Right? So the most important would be these four, I would say. Okay, and this 5, right? So let me talk about this as well little bit. Symbols. So you have a colon symbol, and this colon symbol is used when you want to define a variable, right? So for example, you say, well, x of int type is equal to 10, right? So if you see, well, x of int type is equal to 10, so you are using this, right? So this is what we are talking about here. So this symbol is used to differentiate your variable and the data type. Okay, equal to is used here, right? Equal to is used here. This symbol, right, equal to and greater than is used when you want to separate your I would say block, and when you want to let's say you've written a function, right? So you'll write something like this, list dot map x is equal to do something. Okay, so if you see, when you want to differentiate your function with the body, you will use this as a separator. We will talk about that as we move on. Okay, this symbol is used in your loop. When you say for x, let's say array, right? So when you are using a loop, you will basically use this symbol. Okay, and we will talk about that as we encounter them in our course. At the rate would be used when you want to write some annotations. Okay, apart from that, we will also try to explore other keywords as we move on with the program. So in short, we have this discussion as part of our keywords. So there are 51 keywords and there are 14 soft keywords. Altogether it is 65. Okay, so let me go back to the screen because I want to show you the source from where I have got this information. So I just wanted to tell you these keywords. It says these are the regular keywords. Count them, it will come to 51. They also have few of them like as a soft keywords. Okay, and whatever is not listed, probably they were all removed, right? That's what we can say, because the document is the only source of truth for us, right? Now let's talk about comments. Okay, so you can always write comments in your Scala code, and the comments are basically of two types, right? One is your single line, the other one is a multi-line comment. So single line comment would start with like this, right? And the multi-line comment would start like this, and then you start writing a lot of things and like this. Or you can also write it like this. A few people also write it like this. So these are called as a multi-line, where you can write a lot of comments, the whole sentence. But if you want to write something very short and quick, then you can probably write it in a one-liner. And we'll look into them as we move on with the program. So now we are going to talk about what? Operator overloading, right? Operator overloading. Okay. Now we've already discussed a little bit about this, right? And then I just want to repeat the same thing, that there's no operator in Scala. Everything is basically a method, right? So as you know, like if I say 10 plus 20, okay, what does it mean? It actually means this plus is basically a function. This plus is basically a function which is available in a class. Which class? Integer class, right? So it actually would be evaluated like this: 10 dot plus method, right? And then pass 20 here. And then it basically does that sum and then returns you back what? 30, which would, you can hold it in a variable x is equal to, right? X is equal to. So what will happen is, this is 10, this is 10, and on this 10, plus method is called, which is accepting another variable 20. 10 plus 20 would become 30, and this 30 would be written back to x, and this is of integer type, right? And that's how it works. So in Scala, remember, there is nothing called operators. Everything is basically a functions, and whenever you are using an operator, they are basically a function. Okay, so I'll just go back. That's what we discussed. Like if I say, let me take the same example. Okay, I'll say variable total is equal to num1 plus num2. Let's say this num1 and num2 are basically integers, right? So I'll say, well, num1 is equal to 10, well, num2 is equal to 20, right? So well, num1 equal to 10 and well, num2 is equal to 20. So these are what? Integers, right? And then you're saying num1 plus num2, but internally what it will be executed as is num1 dot plus method, right? Plus method is it's a method name, and you are saying num2, and what it is going to give you, it is going to give you a result, right? And that result is basically been assigned to total. So the total would have what value? Total would have 30. As per this discussion, the value of total would be 30, which is basically another integer. Okay, now there are so many symbols, right? So let's say we have already used plus, you have minus, you have into, you have divide, you have modulo, you have like not equal to, right? You have greater than equal to, you have less than equal to, and so on. So all these are what? All these are methods, right? All these are functions, I would say. All these are functions in Scala. Okay, and they are really not any operators. They are all functions, right? So they are internally all functions. Yeah, so we are actually referring to this notes while discussing the points, right? So I'll go back here and let me just say what I'll say. Well, x is equal to 10, and I'll say well, y is equal to 20, right? So well, x is equal to 10 and well, y is equal to 20. And what I'll try to do is I'll say x plus y, right? And this is basically looks like an operator for us, but it is really not. And then I'll say, well, result is equal to x plus y. So what it gave me? It gave me x plus y is 30. Perfectly valid. Okay. Now, can I do something like this? I'll say x dot, right, plus method, and let me say y. Can I do like this? Yes, in fact, it actually internally does this, right? So plus is basically a method. How do you know? It's very simple. You just say x dot, okay, x dot, hit tab. Okay, and when you hit tab, it will give you the list of all the methods that you can call, right? For example, see here, if I say x dot max, right, or maybe if I say x dot equals, or if I say x dot 2byte, right? So what are these guys? These are all functions, is not it? And that is what you're doing. You're calling the function on object using an object. So similarly, if you see all these symbols, whatever you can see over here on this side, all these symbols are actually functions, right? All these symbols are actually functions, and they are really not a method. They are all functions available in integer class. That's what we can understand by taking this example. Plus plus and minus minus do not work in Scala. Okay, so you cannot just go and say where, let me do that, where count is equal to 0. I'll do the same thing. Okay, and you cannot say count plus plus. You cannot say count plus plus. So it is saying postfix operator plus plus need to be enabled. But let's try to enable this. Okay, let's try to enable this. I'll say copy and say paste. This is how basically you enable the postfix. We'll talk about that as we move on. Okay, but I just wanted to be really quick now, and I'm just trying to do a count plus plus. Okay, now it is saying value plus plus is not a member of int, which means it's saying, hey, I did not find any method or function called plus plus. How do you know that? So you just say count dot tab. Okay, did you see any plus plus here? Let's check it out. No, right? So since you do not have any plus plus, it is not allowed. Probably tomorrow in some new release, they may introduce a variable or a function called plus plus, which can just add one value to it, right? But then it should be applicable only for var. It cannot be applicable for val, because you are not allowed to change the value of a val. Okay. Anyways, so now if you want to really increment the count, you should say count is equal to count plus 1. That's how you will be basically incrementing the count. Or you could also say count plus is equal to 1. This is also perfectly valid, and just say count and you got the value of 2, and I'll increment it 1 again and it got incremented to 3, right? So there is no plus plus symbol, there is no minus minus symbol. Okay, now yeah, so let's move on. I'll take up one question. Maybe somebody is asking, can I add 2, 3, 4 numbers here? You can say 1 plus 2 plus 3 plus 4 plus 5, right? And you can of course say well x is equal to, right? And you'll get 15. But then internally, don't you think this is something like this, dot plus, right? Dot plus. Now again, is it not internally something like this, right? Again, is this not internally something like this, right? And again, is this not internally something like this, right? So this is how the numbers are actually added. So when you say 1 plus 2 plus 3 plus 4 plus 5, this would basically be something like this. 1, on it I'm calling plus method by passing 2, and the result what I'll get on both of this, right? On this again I'm calling plus operator passing 3. Again on the result of this I'm calling plus method by passing 4. Again I'm calling plus method by passing whatever we have got and by passing 5, and that's how it would be basically evaluated. Now see, you can have a numbers also, right? So you can say 1.2 plus 1.4, right? And what I got is this number, and this time this plus operator is called on double. So I can say 1 plus, see, I can say well x is equal to 1.2. So this is clearly a double, and I can say x dot give tab. Okay, give tab, whatever you can see you can call it. Okay, whatever you can see, whatever symbols you are able to see, those operators you can easily call, because they are all functions, right? So which one you can call, when you can call, that totally depends on what are the methods available for that particular object, is not it? So here if you see, you can just say you call plus, you can call minus, and all this as operators. Okay, all right, so let's move on. Okay, now operators. All operators are actually methods. Below table shows the list of operators. So arithmetic operators, they are like plus minus into divide and modulo. Relational operators, less than, greater than, less than, equal to, less than, greater than, equal to, not, and so on. Equality, equal, equal, and not equal to, right? Logical, short circuit operators, and or, and then bitwise, and or not, XOR, right? So these are all the operators which is supported in Scala, and as I have told, they are all internally methods. There is nothing called operators, even though we call it operators, but they are internally a method. Okay, next. Now if you ask me to classify these operators are classified into 3 types. Okay, number 1, it is infix. Number 2, it is prefix, and number 3, it is postfix. So let's talk about this little bit, because it's really important. So what we are going to talk about now is we're going to talk about type of operators. Okay, so type of operators. So what you have is you have infix, you have prefix, and you have postfix. So these are the 3 type of operators, right? Now let's take an example of what are they, right? So we will talk about this. I'll go step by step. I'll go as per the document. So first we'll talk about infix operators. Okay. Now infix means what? In middle of something, right? So if I have number 1 and if I have number 2, and if I want to add both these 2 numbers, then I use a plus symbol, right? And here this plus is of course is basically a function, right? It's basically a function, but we are using this as an operator here, right? And if you see, this plus symbol is exactly sitting in the middle of the two operands, right? So these are variables. These are variables, or you call it operands. Operands. Okay. So these are called as operands, and this is basically an operator, right? So this operator, this symbol is sitting exactly in middle of two variables, right? So this is called as infix because they sit in the middle, right? So this is called as your infix operator. So plus here is acting as a infix operator. Okay. Next, we talk about prefix. So in this prefix, what happens is you have a value called you have a variable called num1 whose value is 10, right? I want to negate this. I want to find the negative number of it. So what you will do? You'll say minus here, right? And what will happen? This minus operator is a unary operator, of course, right? Minus this minus symbol will change the value of a number from a positive to exactly negative, right? But then if I talk about operator's point of view, this is called as a prefix, right? Because this is at the beginning, right? It is not in the middle, it is at the beginning. So this is called as prefix operators, right? So these are called as a prefix operator because this stands at they stay at the beginning, right? Now let's talk about the postfix operator. Okay, so we'll talk with respect to example as well, but right now I'm just trying to give you a bit a bit of understanding. So post operator. So post operator means what? It should be placed after your variable, right? For example, see, let's say I have a number whose value is 10. I want to convert this into float or maybe double. Okay, so I'll say num dot to float. And what is this to float? This is basically a function. It's not it. This is basically a function. Okay, but where are you calling this function? You're calling this function at the end. Okay, can I say number and can I just ignore this dot and just use to float? Probably yes. Okay, now and if you are doing this, then this to float is basically acting as an operator, but you have specified that at the end, and hence this is called as a postfix operator. Okay, so at a very high level, this is what it is. We are talking about the infix operator, right? So as you see here, I'm just trying to say, well, sum is equal to 1 plus 2. Okay, well, sum is equal to 1 plus 2. So what is happening? 1 and 2 are variables, they are operands, and plus is basically a symbol, and they sit exactly in the middle, and hence we call it an infix operator, right? As we have discussed. Now let me try something like this. Okay, so you will be really amazed now that how a Scala is so beautiful. Okay, so see here, I'll say variable message equal to hello world. Done. Now let me do a substring. So let me do a substring. So what I'm saying message dot substring of 4. What it is going to do? It is going to give you the substring of string, right? So see here, I got here OWORLD. Let's understand how it worked. Okay, so I said substring 4. That means 0, 1, 2, 3, 4. Okay, so 0, 1, 2, 3, 4. That means from 4th index, give me everything, and that's what you got here. Oh world. Okay, let me just change it to 3. Okay, now what I got is I got LO, right? So 0, 1, 2, 3. From 3, that means from this L. Okay, I got LO space world. Okay, now what I want to tell you here is, let me do something like this. Let me try doing something like this. Okay, see here, it gave me the same output. So can I say this substring looks like an operator to me because it is sitting exactly between message and 3? Do you all agree with me on this, guys? So substring is actually a method, right? It's actually a method, but then it is sitting exactly in the middle, and I was able to get rid of this dot here, and I was able to get rid of this braces here, right? So this is the beauty of Scala, right? Now think about it. Any method can be treated as an operator because of this property. Okay, because of this property, you can use any method as an infix, and that should work. Now if you remember, then the substring has another overloaded method as well. Okay, your substring has another overloaded method as well, which means you can also write your substring method like this. See here, I can say I want to get the substring, but from 4 to 7. Okay, so let's try that out. Okay, so I'll say message.substring 4, 7. Okay, and what I got is I got the output OW. Let me say 4 to 8. Okay, and what I got output is I got OWO. Right, O space WO is the output. Let's see how exactly this output we have received. So again, I'll start from here. Okay, so 0. Okay, I'll start from here. 0, 0, 1, 2, 3, 4. Okay, so it starts with O, 4, right? 5, 4, 5, 6, 7. So what happens is whenever you write 4 to 8, it starts from 4, it goes till 8 minus 1, 7. Okay, so 4 to 7, it does not go till 8, because that's not how string works in Java as well as in Scala. So if I say 4 to 9, then what it should give me is, it should give me the output from 4th till 8th. Okay, so what the output you are expecting out of this? You are expecting output like 4 to 9, right? So let's see this. So 0, 1, 2, 3, 4. So it starts with this. This is 4, right? O is 4. So 0, 1, 2, 3, 4. This is 4, 5, 6, 7, 8. It does not go till 9. It goes till 8. 9 minus 1. Okay. So you get O space WOR. Right, so that's what it is. Now if you want to convert this into the same style, then you cannot get rid of this braces in this case, because there are 2 arguments holding it, right? There are 2 arguments holding it, but you can still write it like this. And here the bracket was mandatory because you have 2 elements, two parameters to pass. So if a function accepts only 1 parameter, you can ignore the bracket. Okay, if the function expects you to pass 2 parameters, you will have to put them inside your bracket, and that's how it works. So there's a question: is it only because the string class has a substring method, so we can write like that? Yes, it is absolutely correct, right? Because when you write this, then it is automatically converted to this, is not it? And hence it's very much important that your substring method should reside on your string class, because you're calling it on message. And message is basically a string object. So we talked about this, right? And then this is how you will be basically able to use them. Okay, you can either keep a space, or let me also try without a space. So let's try without a space, and let's only give it like this. Okay, so this also works. There is not it is not necessary that you have to even give a space in this case. If the method takes 2 parameters, we have already discussed that if the method takes 2 parameters, then while using the method as operator, we need to specify both the parameter within bracket. But if the method takes only 1 parameter, then you don't need to use the braces. So any method can be used as an infix operator in this approach. Okay, now we'll talk about prefix. Okay, so prefix, if you see, in prefix we put the method name before the object on which we are invoking the method. For example, in this case, see here, I'm just saying, well, number is equal to minus 100. So say enter. Okay, well, where number is equal to minus 100. So what are you doing? You are actually using this minus, right? But is this minus operator? This is basically a method, is not it? And it internally goes and calls a method. Okay, and what is the method? You may ask, what will happen if somebody calls this minus 100? Okay, so see here, let me do what I'll just say number dot tab. When I say number dot tab, do you see there is something called unary plus, unary minus, unary negate? So these are basically invoked. Okay, so these are basically invoked, which gives you a negative value. So let me try that out. I'll say unary underscore minus. Okay, let's see what exactly it gives. Number is minus 100, right? See here. So the number is minus 100, and I said unary underscore minus. It gave me minus of minus 100, right? Which is basically plus. So that is what has happened. So that means if I call minus 100, then it goes internally goes and calls 100. It basically goes and calls unary minus is a method name, right? So it basically goes and calls this method. Okay, and this method is responsible to return you the negative number of what it has actually received, and that's how it works. So now let's try to look into this. Okay, so I'll just say flag, let me type it out here. I'll just say where flag is equal to not true. Okay, so I said where flag is equal to not true. So let me go to flag is a boolean type, right? It's a boolean type, and if I'll say dot enter. Okay, now see here, in this case you have a unary underscore not, right? So what I'm trying to tell you is whenever you call -100 internally, that goes and calls -100 dot unary underscore minus method. There is a method with this name, and this basically gets called, and this method is responsible to return you the negative of whatever is the input. If the input is negative, negative of negative would be positive. If the input is 100, then 100 of negative would be -100, right? So let's try this. I'll say where number is equal to 100 dot unary minus of unary underscore of minus, right? This is what will be called whenever you just say -100. You are just saying -100, but within the background it basically goes and calls this particular method dot unary. So similarly, let's do what? Let's try to say I'll remove this, I'll remove this, okay, and let us try to do it like this. Okay, so if you see, this has also given me the same output, 100 space unary underscore minus, right? But can you tell me, is this a infix operator? So this is not infix. Okay, I would call it postfix. It's not it. So you should basically call it a postfix. It is not infix. It is basically a postfix, right? Because in infix, what should happen? You should have two variable, and this unary method should sit in the middle, right? But here you have only one variable. So if you write it like this, then it is basically a postfix, not infix. You got me correctly. Okay, so now let's talk about how can you use your own prefix operators. Okay, you want to create your own prefix operator, which means I want to create an operator which I can use on my custom object. That is also possible. And how do you do that? Is like there are some limitations. The limitations is the only identifier that can be used as a prefix operators are plus, minus, not, and negate. If you want to create your own unary operator, then the only allowed symbols are this by Scala. Okay, now if you plan to define a prefix operator in your class, you can just use the above four and call them using operator style. If you define a method called unary underscore not, then you can call it directly using a not method. It's very simple. Okay, but if you define a unary method like this, unary underscore into, then you cannot call that method by just using star, because this star does not come under this 4. Okay, and if you still want to call this, then you'll have to call it like this, object dot unary underscore star. Okay, so let's take this example. So I'll also update one thing here. I'll say works on Scala 2 and does not work on Scala 3. Okay, I've tried this. It works on Scala 2 and it does not work on Scala 3. What you need to do, let's try to understand this example. Okay, so what I'm doing is, see, we will talk about these classes and all little later. It's not the right time, but right now I'm just trying to show you the example. Okay, so you can again correlate this once you're done with the classes and object concepts. Okay, so what we have done is we've just created a class called employee, right? Class employee, and let us say you have 3 variables here: name, salary, and type. Okay, name, salary, and type. And we have defined a method called unary underscore exclamation. Okay, is a boolean type, and I'm saying employee type equals ignore case permanent. If the employee type is permanent, then you return me true, otherwise not, right? So that is what it is going to do. Similarly, I've also defined one more function called unary underscore star with a bracket, and I'm saying if I get this into, then you just multiply the salary into 2 and return me back that. So if you see here, I've not here the return type is what boolean, and here the return type is what integer. Okay, and then I created an object wherein I'm saying define main. Okay, and then I just created the object of employee class, and I'm just trying to print this. So let me do what? Let me try to execute this. Without writing a class file. Okay, and then we will see that what exactly it does. So the first thing is I should define this class. So let me define this class. I've copied this and let me say paste. Now if you see, I've created a class called employee, and this class employee accepts three parameters: employee name, employee salary, and employee type. Okay, and now what I'll do is I'll not write this object and all. So let me directly create the object of employee class. So I created the object of employee class, and I'm saying the employee name would be Suraj, employee salary would be 5,000, and employee type, let it be permanent. Okay, this EMP, right? So what is the class of this EMP, guys? And if you look into this employee class, in this employee class, do you have a unary underscore exclamation, and do you have unary underscore star? Yes, right? Out of this, what supports directly? Not symbol, unary underscore exclamation, which means, can I try doing something like this? Underscore not of employee. Okay, not of employee. So when you do this, then it works in Scala 2. Okay, and it does not work in Scala 3. See here, it says unary, this in class employee must be called with arguments. I'll say emp dot tab. I have emp dot, and let me try to call it like this. Okay, I'll say unary underscore not. Okay, so this is also not at all working, right? So let me also say star, right? So this is what not at all working. This works pretty well in Scala 2. So to demonstrate that, let me go back, and so we have our Ubuntu back. Okay, let's try to start using Scala in that. Okay, so I'll just go back here and I'll just say Scala. So we got Scala here. I'll do the same thing now. Okay, whatever we have done here. So let me create a class called employee, and this is basically Scala 2, right? So I created a class called employee, done, and let me create the object of this employee class. Okay, and let me try to do not of employee. Okay, now if you see, it gives me true or false, right? So it allows me to use this as a operator, as a unary operator. And then the same thing is not exactly working in your Scala 3. In Scala 3, if you just say not of employee, then it does not work. It says, hey, you must call it with argument, and then you are only left with calling it like this, dot exclamation, like this, right? So you're only left to call it like this, but ideally this should have worked, right? So that's what we should be basically doing. Now if I talk about this symbol, right? Now see, you are allowed to call this employee like this. Okay, but then you are not allowed to call, see, in this case, in this employee class, I have created two unary operator. I have created two functions with unary underscore, right? One is exclamation and the other one is what? Star. And this star is not in our list. Okay, Scala list says you can only have plus, minus, not, and negate. Okay, out of which we use this not, and then this is not in our list. So you should probably not be allowed to call the method with star symbol, right? So it will say it is not allowed. It will give you an error even though you tried your best. So the only way to call this star would be, you just have to call this as a regular method. Okay, unary underscore star. See here, it is allowed to call it like this without a braces, right? And that is what is not happening in your Scala 3. So in Scala 3, let me try doing it like this, right? So if it was working there, and then this would also work here, is not it? So that is what is the beauty. This is what the beauty of the differences. Okay, so whenever I get any such differences, and if I am able to find out the exact reason and all, I'll definitely put it over here. Okay, now let's move to the next example. Okay, so now the next example is on postfix. We understood what is a prefix, we understood what is an infix. Now we are going to talk about a postfix. Okay, so postfix means what? You can put them at the end, right? Like after your object, you can use that, right? So let's try this out. What I'll do is I'll just create a function. I'll just create a variable called number, and I'll assign 100 to it. So number is of integer type, and I've just assigned 100 to it. Now I have a requirement to convert that into a long. So what you can do is you can use any 2xxx method to convert that into appropriate type. So I just wanted to convert that to a number, and I said number.toLong, right? Again, if you remember, this toLong is also a method ideally, right? Which does not take parameter, of course, but this is a method. But then it does not allow you to do this. Okay, so it just says toLong is basically does not take any parameters, so you should not use it. I'll tell you the reason. I remember now. I'll tell you the reason when I will discuss the functions. Okay, for now, just understand that this did not allow you to use it on a braces format. Okay, why it happened? I'll tell you the reason when we start the function class. We are only left with what? We are only left with the toLong, right? So now what I can do is probably I can go back and say number, and I'll just remove that dot, and I'll just say toLong, right? And it gave me a variation of it. And if you look into this example, can I say this is a function which is used after the object name, right? And can I call it a postfix now, right? Can I call it a postfix? Yes, right? So that's how it works. Okay, so if at all you get some error like this, error postfix operator should be enabled, then like in this whole error you will see there's an import clause. So all you need to do is import this, and if you import this, then you will be able to use this and without any warning at all. Okay, so number of toLong would give you a long number. You can access it to a variable and then start printing them, and that's how it works.